Alright, so this video here today is going to be about solving right triangle word problems. And so if you're just starting a trig class and you've gotten some right triangle trig, these would be a couple of word problems that you might have that are pretty basic. And then I've got one that's a little bit trickier, so we'll see how it goes. But I've got a couple things planned for us. There's some wording that you're going to want to make sure you get. And then part of this lesson too is also just you want to be able to draw good pictures, because if you have a good picture, then you'll be able to solve this. And you know, the nice hint here is that all our pictures should be using right triangles. So if we're not really using a right triangle in your problem here in this video or in your homework, well then you probably don't want this information. If you're using other kinds of triangles, you can find a different video on things like law of sines and law of cosines and things like that. Alright, but here we go. Let's get started. So in these word problems, you're going to see two common expressions. Not always, but they're used quite often. And the first one is called the angle of elevation. And so I'll just make some ridiculousness to try to help us understand this a little bit. So let's say we got this guy. He's right here. Right here he is, stick figure. Some dude, Mr. Yasuda right here, and he's looking straight ahead. Okay, let's say that he notices a bird, a plane. No, it's Superman, right, in the sky. There he is, there's Superman in the sky with his cape, and I don't know, his hands are out, maybe, something like that. Looks more like a bug. But anyway, either way, there he is, right? He notices him at an angle of elevation of 15 degrees. Okay, boom. So angle of elevation is always from a horizontal line, so hopefully you can see me. Just drawing that dotted horizontal line, and then the angle of elevation is always rotated up looking at the figure. So there's my 15-degree angle of elevation. Your angle of elevation always has to come from a horizontal and then always looking up, and then you can say, okay, well, how high off the ground is Superman? See this right triangle that's forming? Yes, right? So that's important, that the angle of elevation comes from a horizontal. All right, let's say that now in your angle of depression, right, it's kind of the other way. Now let's say that Superman is in the sky. Here's his cape. Yes, he's flying along, hands out, eyes searching for people in distress on the ground. And so let's say that he sees Mr. Yasuda down here struggling with a math problem, and he's going to help me. He's going to come to my rescue. So horizontal line would be the trajectory that Superman's flying at, and then he's looking down at Mr. Yasuda at an angle of depression of, let's say, 45 degrees. Well, then that would be where 45 degrees is. Okay, so once again, the angle of depression has to come from a horizontal, just like the angle of elevation. And this is really important that you call the right angle the right thing, otherwise you'll have the wrong picture and you will end up with the wrong answer. So as you can see, here would be a right triangle, and we could say how high or maybe how far away. We could start labeling it with different places, and we could start solving the right triangle in order to figure out how far Superman's got to go to help me with my math problem. Okay, so angle of elevation, angle of depression. If it's not that, hopefully the picture can be understood through the description, or sometimes you might get lucky, they'll give you the picture, which that's a jackpot. Okay, so here we go. Let's do one with the angle of elevation. It says the angle of elevation of the top of the Empire State Building in New York is found to be 11 degrees from the ground at a distance of 1 mile from the base of the building. Using this information, find the height of the Empire State Building. So I know that kids hate word problems because it's hard to make sense of the word problem, but let's just say this. What are we trying to find? We're trying to find the height of the Empire State Building. So let's say let X, Lex Luthor got Superman on the mind. Let X be the height. Right? So X is going to be the height of our Empire State Building. So let's draw a picture. Here we go. Here's the Empire State Building. Boom. X is the height. Now it says that the angle of elevation to the top of the Empire State Building. So that's critical where it says to the top of the Empire State Building. So it doesn't mean that as we look down from the top of the Empire State Building, that is not 11 degrees. So right here, not 11 degrees. Boom, bad. Okay, not 11 degrees at all. It says to the top, so from the ground to the top, here's my ground, and then it says from the ground, right, at a distance 1 mile. So this is 1 mile. And this would be your angle of elevation going from the horizontal looking up to the top of the Empire State Building, and there is the appropriate picture with your right triangle. Okay, take a moment to pause the video, take a moment to read the word problem one more time, and to look at my picture so that you can see how that makes sense. All right, now we're going to use some trig though. Got to use some trig. So we want to use a trig function to solve for x. So look at what you've been given. You've been given this angle 11 degrees. You know the adjacent side of the angle, and then you're looking for the opposite side. So what would use the opposite and what would use the adjacent? And hopefully you're saying tangent. So we do tangent of 11 degrees would equal x over 1. And so then obviously that's just x on that side. So whatever the tangent of 11 degrees is, that is going to be what x equals. So if you've got your calculator, you're going to want to make sure that it's in degrees, and then you'll do the tangent of 11 degrees. And you should get x equals 0.194-ish miles. Now, it would be weird to say that the Empire State Building is 0.194 miles tall. So somebody might ask for this in feet. So if you remember, the conversion is 1 mile is 5,280 feet. So I might multiply 0.194 by 5,280, or tangent of 11, whatever that ended up being, and multiply by 5,280, so that I could then see what the actual amount is in feet. So 0.194 miles is roughly, let's see, 1,026.33 feet. And so then I could say the Empire State Building is that many feet. So it'd be weird to just say that it's a certain number of miles tall. But anyway, hopefully that makes sense with angle of elevation. All right, let's do another with angle of depression. All right, so here we go. We've got from the top of a 232-foot lighthouse, the angle of depression to a ship in the ocean is 19 degrees. And so you've got, how far is the ship from the base of the lighthouse? That's what we're going for. So first, we're going to say let x be the distance from the ship to the lighthouse. Okay, hopefully that makes sense, because that's what I'm trying to find. All right, now let's try to draw this picture. So here we go, beautiful picture, lighthouse, bang, 232 feet tall. Okay, and then there's a ship, right? Ship. I don't even draw the ship. Ship. Just draw a dot. Okay, and so we're trying to find how far the base of the lighthouse is from the ship. There's x, right? And now angle of depression. So remember, angle of depression has to come from a horizontal, and it's looking down at the ship from the top of the lighthouse. And so the deceiving part about the angle of depression is to think that the angle of depression is on the inside of this triangle that we've drawn, but that'd be incorrect. This is where it is. This would be 19 degrees. So you've got a couple ways that you can go about this. You can draw a triangle this way, because obviously this would have to be 232, and this would also have to be x, so you can do it that way. Or you could try to find the missing angle on the inside and go from there as well. It's really up to you. It all is just dependent on how you see it. So I'm just going to go with the 19 in the top triangle. And so I'm going to use tangent again, tangent of 19 degrees. But remember, it's opposite, so 232 over x. Then we're going to multiply by x, so x times the tangent of 19 degrees equals 232. And then I'm going to divide by tangent of 19, so x would equal 232 over tangent of 19 degrees. And once again, just make sure your calculator is in degrees, and you're going to be okay. All right. I plugged that into my calculator, and I got that x would equal approximately 673.78 feet. So roughly 674 feet away from the ship. That's where the lighthouse is. Okay, and so that's angle of depression, angle of elevation. And so now we're going to do one that's a little bit crazier. So here we go. Feel free to hit pause and practice some of your homework with those, but we're going to do one where you have to use multiple expressions. All right, so, or multiple trig functions. So here we are. It says a survey team is trying to estimate the height of a mountain above a level plain. From one point on the plain, they observe that the angle of elevation to the top of the mountain is 32 degrees. From a point 1,000 feet closer to the mountain along the plain, they find that the angle of elevation is 35 degrees. How high in feet is the mountain? All right, so if you've never done a problem like this before, then just kind of picture this a little bit with me. So you have this group of people. I'm going to draw the ground. That'll be helpful. Here we go. Ground. All right, so you got some ground here. The survey team really wants to know the height of this mountain. Super essential. So let's just say that this is the height of the mountain, right? How high is the, I'm going to call it h. So let h be the height of the mountain. All right, hopefully that works for you, works for me. H is the height of the mountain. So you've got this group, they're here, and they look to the top of the mountain. So the angle of elevation, right, from a horizontal looking up, they say the angle of elevation is 32 degrees. Okay, then it says that they go 1,000 feet closer. So I'm going to just draw another dot. Right here, this is 1,000 feet. They're saying now the angle of elevation to the top of the mountain is 35 degrees. And that's all they tell you. And you want to know what the height of the mountain is. And this is where you are. So I have watched lots of people try to solve this. The problem is if you only know right triangle trig, you can't solve it by using this part. Let me show you. A lot of people will want to go and try to find all the angles here in this non-right triangle. Do you see where I'm highlighting this? The problem is you don't know how to solve when it's not a right triangle. That would require law of sines or law of cosines, and we're not working with that in this video. I'm sure you could find a video on law of sines and law of cosines, but we're not doing it. All right, so there is a way to do it with just right triangles. So how could we go about doing that? Well, first I'm going to introduce another variable. So take a look. I'm going to call this just x, okay? And so let x be the distance, right, from the survey team to the base of the mountain. Does that sound okay to everybody? But I want you to also notice two right triangles. There's this one, the big one, is what I'll call it. Okay, and then there's one more, which would be the smaller one. So right here. So if you notice, I've got two right triangles, and they both will incorporate x. Okay, I'm actually going to draw them for you so that you can see them. So here's the one that I outlined, right? So you've got this guy, and that would be 32 degrees. This is h, and this is, hopefully you would agree, 1,000 plus x. And that's my first right triangle, the big one. Then I've got the smaller one, which would be, right, 35 degrees here. And then there's my right angle, and this is h, and this is x. And if you take a look, they both incorporate the variable h. And I'm going to be able to solve this by using some substitution and being able to find everything that I need. So take a look, here we go, right? Let's write a trig function for this one. Hopefully you would agree that I could use tangent, and tangent of 32 degrees would equal h over 1,000 plus x. And then for this guy over here, I would say tangent of 35 degrees equals h over x. Now if you think about it, we are trying to find h, not x. So we're trying to find h, not x, if you're thinking about it in that manner. So there's a couple ways you can solve this. Now some of this gets dependent on your teacher and on your calculator and what you have. But if I am your teacher, which is a high possibility since many of my students watch Mr. Yasuda's math videos, but if I'm your teacher, then you can set up one equation and then use our calculators to solve it. So I want to find h, right? It said find the height of the mountain. So what I'm going to do is, in this problem over here, I am going to get x alone. So I'm going to multiply by x. And so I'll have x times the tangent of 35 equals h. Whoops. And then I'm going to divide by tangent of 35. So x equals h divided by the tangent of 35. And then I'm going to substitute in what x equals into here. And so we've got ourselves this crazy looking equation. Tangent, right, of 32 degrees equals h over 1,000 plus h over tangent of 35. Now if you have a calculator that can just solve that right out, more power to you. If you do not have a calculator that can solve it, I probably would have solved this a little bit differently. But I'll just tell you that h now can be found in a couple different ways, but if you really got to do all the work out, you'd probably want to do something like cross multiply and then go from there. It'll be really ugly. So use a calculator to solve. So if you have a calculator that can solve it for you, you've got yourself 5,807.66 feet. All right? And so you would have to use a system of equations in order to solve that. If you do not have a calculator that can solve it, I will solve it now without a calculator. But if you have a calculator that can solve it and you know how to solve this equation with your calculator, then you can stop the video now. But if you don't, this is probably the better way to go. So you've got tangent, tangent of 35 equals h over x, and you've got tangent of 32. All right, tangent of 32 equals h over 1,000 plus x. So if I'm probably solving this without a calculator, I'm probably actually solving for h. So I'm going to multiply by x, and that's what h would equal, x times tangent of 35, and then that's what I'll substitute in up here. Tangent of 32 equals x times tangent of 35 over 1,000 plus x. And then that way you can think of this as a proportion, and you can cross multiply. So you would have x times the tangent of 35 equals 1,000 times the tangent of 32 plus x times the tangent of 32. You're going to have to distribute that. Then I'm going to get the x's all on the same side, so I'd subtract. So I'd have x times the tangent of 35, minus x times the tangent of 32 equals 1,000 tangent of 32. Factor out next, so you'll have x times tangent of 35 minus tangent of 32 equals 1,000 tangent of 32. Then you can divide, and so then x equals 1,000 tangent of 32 over tangent of 35 minus tangent of 32. But then you need to remember that that's x, and remember x times the tangent of 35 equals h. So once you find this number, you'll then have to put it in for x, and you would then have to multiply it by tangent of 35 in order to equal h. And so you'd find x, then plug it back in and find h. And that'd be the way to do it if your calculator is not going to solve it for you. It's less messy. All right. Hopefully you enjoyed the video. A little bit longer, but thanks for being here. Have a great day.